Alright guys, welcome back. This is Ruby tutorial number 16 part 3. We are going to continue building our Chrono Trigger type battle system, and just to give us a better idea of exactly what we're looking for out of the battle system and so on, I've actually downloaded the ROM and set that up so that we can just quickly see how the actors each go to their places, etc. as soon as the battle starts. And one thing to note first is that in this they do in fact they have a caterpillar system so that the actors, all of the actors in the party, are following. So I'm sure I'll get a request out there to make this compatible with some caterpillar system, but initially I'm not going to make it that. And if you want to do so, it should be just modifying this go to position code data. So just so that you're aware of that, so that you know, each of your people will go to their place, and so on. So let's go ahead and get this going here. So here you've got just your character. You come up here and you talk to Gato here. And as the battle starts, your characters, they'll just run to their positions, and then as soon as that happens, then the battle officially starts. And then, as you can tell, you automatically get a selection bar here. You can use left and right to switch between which character is currently active. And the enemy here, he just sits here and continuously wanders around in the background. Now, when you attack, he will counterattack usually, and he will always counterattack whomever is closest, even if that is Marl instead of Chrono, who's clear down here. One thing that you just barely saw right there was also that you have a critical attack, screen flash, and a combo move to deliver additional attacks. And so we're going to try to capture all of that as we go on. First off, we're just going to go through getting each of them to their positions, and we'll proceed from there. So the one thing, if we go back and we look at our map here, we have defined an enemy position, or I'm sorry, those are actor positions. That's actor 1, 2, and 3. And then our battle starting event, and then each of these here have no graphic set for them as far as who they are, etc. The enemies, they do have a graphic set. So what we need to do is we need to say each of the players. So what we're going to do is we're going to take each of these events and we're going to move them up to where the player is at when they trigger the battle, and then we'll have them change their graphic to be the appropriate battler. And then what we'll do is we'll have them run from there to where they had originated. So what we're going to do is we're going to say for each actor in the actor code, and we actually need to set this up before we do the actual move. So what we need to do is probably add in a if prepared move, and then that will be all of that code. And then the else is that they have not prepared for the move. Wow, I cannot spell. So if they have not prepared for the move, then we need to say that they have prepared for it. And we're going to set that to true. Now, do recall that all of these all these flags that we set up, we're going to have to go back and remember to remove all of these in order to back out of battle, so that you can re-go into battle later with other people and whatnot. So the prepared move is going to look at each of the actors here. So we're going to say, so these here is going to get our actor indexes, okay? And our actor index is, it'd be helpful if I actually spelled that right. See that? Just caught a mistake. Anyways, so what we're going to do is we're going to grab the actor to index, and then we're going to ask it for its values. In other words, what actors are going to be called to the field. And then we'll sort those. I wonder if maybe we should actually do it the other way around, to the event ID on this side of the equation rather than on this side. That way you could just say actor index, and not a big deal. Either way, it can be done. It's just possibly more troublesome to do it this way, but not a big deal. Either way, you'll learn something. Alright, so what we want to do is we want to ask it for its values. So being that this is a hash has keys and it has values. The values is the results. It's an array set of all the results of what you would get if you passed it the keys. And the keys is obviously the event ID in all of these cases up here. So it's easier to just say update this event. Is that event ready? And then we can just say, all right, well, what actor are you? And then it will return the index of the actor that it belongs to. So that's kind of the general idea that what I've got going on here that we're going to use. So we're going to say for each of those, and really we don't even have to do it that way. We can just say for key, you know what, I really want to do it by values, but then I have to reverse sort it. Oh well, I guess I'll do it anyways. So we'll paste that dot values, and this is going to be for index in and values dot sort. So it's going to sort them numerically. And then we are going to find out, so that will tell us how many indexes, how many places we have for actors to go. So the next part of that is to find out or assign each of those an actor. And really, the only reason of doing this is to determine, I guess what I'm trying to get at, and sorry for bumbling around here, but the idea here is that we don't want to ask for an actor who doesn't exist. I mean, I guess it's not a big deal if we do. We can just add some handling in so that it doesn't care. But I like to just try to make sure it's as clean as possible from the get-go so you know what to expect, meaning your code doesn't have to have a whole bunch of, well, if it doesn't really exist, then do this. Type stuff. And so it's generally better and more optimized if you did it that way. However, it's not necessarily bad if you have invalid data in there. It just means that you have to sort through that invalid data every single update frame in order to determine who needs to go next, etc. So what we can do, and maybe this is actually better the better place for it, but back here when we reset the we set the in update events. No, that wasn't it. It's right here. We said, are you in battle? So what we could do is we could just say, if you're in battle, then go ahead and set your character name or your source character as the actual battler. Maybe that's the way to do it, because then it actually reduces how much work we have to do up here. I actually like that idea. So what we're going to do is we're going to store the positions up here then. And that's going to be an array for each of the actors. Let's do it as a hash, and we'll do it based on event ID, and that way there we can actually plug that in. So again, sorry for bouncing around, but I'm still trying to formulate how to put this all together. So we say they are in battle. Okay, so if they are in battle, then we set the pose. But let's also set the character name and so on according to the battler. So I guess what we need to do is we need to check this to see whether or not it's an actor. And if it's an actor, then to set it to one of those. So we're just going to do if name dot include actor. And I guess if you wanted to have neutrals as well, then you could do that as well. So you just do else if name dot include neutral, like that. In which case either one will poll the actor by the index. I would assume neutral is actually going to poll them based on more than likely the actual ID, so that one will return the actual ID, and this one here would actually return the character according to the party index. So we go ahead and get actor equals game party dot members, and then what we do is we use the name, and we say dot down case dot delete actor dot to integer. So the remaining portion of the name is going to become an integer. So actor 1 becomes actor 1, and then what we do is we minus 1 from that so that it's the actual index correlation, and then we close that off. So here we can, I guess we could just put this right here. We say index equals that, and then you could say member index, if that makes it a little bit easier to read. So that way there you've got your actor. So now we're going to go ahead and set the character name and the character index. I believe that was what they called it. Let's see, back at game character set graphic, and it wants character name and index and tile ID. So let's grab all three of those. Go ahead and paste them in here, and this is going to be actor dot and actor dot. That way there it returns the character name for that actor, and then the sets the tile ID to that, so that if they were represented as a tile on the map, then they'll just magically become what they're supposed to be. And then likewise for down here, the only difference is rather than searching game party for the actor, and we're actually looking for neutral here, and this is not going to need to minus that from it, and then this is going to be game actors and then index, and then that will return the actor index, or I'm sorry, the actor, the actual version of them, in which case then of course the same information applies and they would go ahead and be called to battle. So if you wanted to do your actors based by ID rather than by party index, then you would just change that minus to just not minus it, and then rather than looking at game party, you look at game actors here, which is the actual actor, where game party members returns the actors in which are part of the party. So hopefully that all made sense. So we set the graphic, essentially, is what we're doing here, is we're just saying if you're an actor or a neutral, go ahead and set the graphic according to the character name and character index that they are. So now that we've got that, we'll come back up here and we'll say, all right, so we know you're supposed to go to this position, but we don't want you to go to that position. We want you to go to the game player. Okay, so before we have them go to the game player, that's where they're supposed to go, right? So we're going to go through each one of the actor positions, and we're going to determine what that position is and who has to go there. And I mean, this is probably a bit complex for a simple routine, but at the same time it's still kind of helpful. But anyways, so what we're going to do is we're going to go ahead and say positions, and we are, before we actually do that, we're going to say for actor in, and I believe it was just actors. Okay, so this is going to return the events. So actor in actors. This is, I guess what we could do is we could just call it event, or event, EV. So ev.x and ev.y are going to be stored in positions dot, or not dot, but event.id. Okay, so that basically says, here is the information or here is the XY you need to proceed to when loaded. So we're just storing the current position in this hash so that we can pull it right back out based on ID to determine whether or not you're actually to your position. And then what we'll do is we'll hide the game player, but we'll move each of these to the game player. So now that we've stored the position, now we're going to actually take the game player and get rid of them off of the map. So game player.hide is probably what I'm going to do. So we're going to say game player, and we need to hide them. So game player, and we need to just tell them to go away for a minute, and we're going to set the character name to 0 and that so that they just effectively disappear, although they are still there. And then what we'll do is we'll just call a refresh method when we're all finished, and that should handle that portion as well. So let's just go ahead and we're going to create a new hide method. So game player is less than game character. So let's jump on down here. Class game player is less than the game character. And then we're going to create a method called hide, which is going to set those. And then we're just going to close it. That's all we need to do, because we just need to have them disappear. Okay, and so we're going to jump back up here to our position setup code. We were right there, so game player hide, and then for each of those events, go to the game player. So we're going to say ev dot, and I believe it's just move to, and then we give it game player.x and game player.y. Alright, so that should handle forcing them all to that position quickly. Now the last part is to actually move them to where they're supposed to go to. So we're going to come back to prepared move, and that was up here, so we say, and I guess if you want to have neutrals run to their positions as well, you would just repeat this exact same thing. Actually, you don't even have to, you just do plus at neutrals. So because it's an array, we can quickly get where they're all supposed to go to. So that way there you'll get all the actors and all the neutrals. They'll all be warped to the player, and in which case then they will jump out to their designated position, which was set prior to them actually being moved. So now we're going to have them move. So what we need to do is look at either one, deciding whether a path finding is needing, or forcing an XY position and then just having their character progressively move from one point to the other. Now the easiest way is to actually set the X and Y for the game character, and then because essentially that's all the move up, move down, move left, all that crap is just basically taking a X and Y and just adding it. So here we've got turn, here's our move backwards, move forward, move random, move left, move right. Okay, so here you've just got your X and Y, and you're just saying move. Okay, or increment your X and Y to the appropriate coordinates. So what we're going to do, because you cannot manipulate, and let me show you why you cannot, but because you normally cannot directly manipulate the X and Y, they are just readers, that you can't normally manipulate them. If you try, it'll give you an error message telling you that you cannot do so because, well, it's just a reader. So we can expose that and change those to accessors, or we can create a new method which says, go to position, in which case then they'll actually just move from wherever they are to wherever they're going. So I would recommend that that's probably the way we do it. We leave the real X and real Y as they are because that's their current actual position, and then the X is a calculated position, so then they'll progress from here over to there accordingly. So we are going to change these. I'm thinking we're actually just going to set up a method, and I'm just going to call it goToXY, and that is part of game character, which I believe we've already modified down here. Here we are, and then we just say def goToXY, and then we provided an x and a y, and then we just say x equals to x and y equals to y. If game map dot, I believe the method is valid. We just want to make sure that you're not trying to move off of the map, just in case. Let's see, valid. What is it highlighting? I can't even tell. Okay, valid xy. So let's add a def in front of it so we can't be wrong. Okay, so here we've just got valid, so that's what we're going to do. So the method is .valid, and then we provided the xy, and then if it is valid, then we'll go ahead and set that. Otherwise, it just ignores it and proceeds. All right, so now we've got our goToXY. So now we come up here and we say, so we say hide the player, we move them all, so now we go ahead and we say, you know, I guess we really don't even need to store this, really. Yeah, not really. So what we're going to do is we're just going to say event xy equals xy. We move them, and now we say event.goToXY x and y. Now, the reason I don't need to store it is simply because it doesn't matter. You're going to move. What we're doing is we're just saying capture where they are, move them to the player, and now tell them where they need to go, and then they'll finish the move on their own. So this here, we don't actually need anything here other than for event in actors plus neutrals, and then event.moving, and that is all. So if event is moving, all at pause equals false, and in which case it will then proceed. It'll look back, and you will just continuously do that until everyone gets to their position. I guess if you wanted to, you could force them into, if they're moving, then you could say that, so what we do is we come down here and look at how we were changing the name stuff. So we could just go ahead and put return name, let's see, return name plus quote underscore quote plus walk if moving, like that. So now you can just basically say, well, if you're moving, then always use the walk animation. If you're not, then use the wait animation. And it'll always return that before it returns the pose. Oops. If before it ever returns any pose information. So that way there, technically, you don't even need that line any longer. And so then all you need is your attack, your magic, etc. So what we'll do is we'll undo that, and we'll just call this one here, you know, magic, or you know, whatever you want to call it. Okay, so let's go back up here now. Oh, you know what we did though? Because we did that, we now have to have a walk animation graphic before we proceed. Although mainly that's going to be for the actors. So let's go ahead and export one of these for each of them, not only for wait, but for also for walk. One walk. And then we'll do the same thing here. Wait. this one will be walk. I'm just doing this so that I don't have to create a whole bunch of different sprite sheets. Walk. Alright, so now we've got all of our actor sheets out, and for both weights and walks. Let's just reopen that. Okay, so now you can see they've all relisted up in here now. Okay, so I think we are good to go, at least for a quick test to make sure that everyone is moving to their positions, and then from here it'll automatically proceed to phase 1, which as of right now, battle phase 1 doesn't do anything. So I guess we could just put successfully made it to step 1 or phase 1. And then we could say exit 0 or exit 1. So that's just saying close the window. Okay, so let's go ahead and play test this guy. Alright. We go ahead and step over, starts our battle, and nothing. Pretty sweet. Now we gotta go into troubleshooting mode. So we didn't make it to step 1. It never even made it there. So the question is, why? Part of this is the fact that we're dealing within the map scene. And this is, like I said, this is going to be the more difficult part in actually telling it. The map scene, don't do any of your normal regular updates. Instead, do only this update. And so here we have our update battle, which was was called as of update battle routine, and the in battle flag was not set. Otherwise it would have gone into our routine down there and we would have been good. So in battle, that's set to true right there. And as soon as that's set to true, so let's just go ahead and see if we're making it to here. Okay. Here, move that out of the way here. Okay, so it did go through the setup. So it made it to there, and now let's just see, let's just go ahead and put a 1, and then we'll print a 2 right there. And then what we should see is a 1, and then a 2, and then it'll just progressively keep on putting 2s. Nope, all we got was a 1, and that was that. Now, why is that? Did we even see our 2? I don't recall. Hold on.
Hey Dad, I was watching videos on Taylor's.
Hey, sorry about that. Anyway, so we are not seeing the 2 pop up at all, which means that we are not making it to our this call battle, which makes sense as to why it's not being done, because def call battle in the scene map. So let's go look at that scene map. Def call battle. There I go, doing it special like. Alright, so that was the set all of that, and then this scene here has to remain as battle until we actually get finished. In which case, when we finish, we'll reset the next scene as map, or we'll just set it back to nil, in which case it won't do that any longer. So let's just go ahead and we'll put a print 2, and we'll just leave it right there and make sure and see if we're making it there. So we get our 2, cannot convert name for undefined method name for array, and our array event in events.values is actually, because that's a hash, And let's try that again. So now we're getting our 2.